Good morning to all. Myself Dr. K. Manoharan, Associate Professor, Department of Biomedical Engineering. So today class we are going to discuss about indexed addressing mode for memory data. So already we have seen the basic addressing mode like a register addressing mode and then immediate addressing mode. And for memory addressing also we have seen this direct, again indirect using register and indexed addressing. So today class we are going to deal about indexed addressing modes for that particular memory data. Look at this indexed addressing modes. So here indexed registers like an SI or DI will be used for that holding that effective address. So these two registers alone will be used plus this offset also we can use it. So up to 16-bit displacement offset can be used with this indexed register also. So this displacement value will be added with SI or DA register. After that this will be considered as an effective address. So from that location data will be accessed. So the effective address means again we need to consider that physical address will be equal to the data segment into 16 plus this effective address. So these will be gives an physical address. Look at this. So in case of 8-bit displacement, we can use an assigned 16-bit before adding that particular values. Look at the example. Move Cx comma square bracket of Si plus 0A to H. So here is a H indicates a hexadecimal. Again 0A2. Actually A2 only data 0 is inserted. Why 0 is inserted means the data should be start only with number, no alphabets will be allowed. See, actual data is A2 only. A is not a number, it's an alphabet. So A is not allowed. That's why we put here 0. But actual data is only A2 only. So this A2 only alone added with SI. So it should start with number. That's why we are putting a 0 here. Look at this corresponding example. So the SI register will be added with A2 value. So this will be considered as an offset address. So this address will be considered as an offset. So the base value, that is a segment base register into 16 plus this value gives an physical address. The content present in that physical address will be moved to CL register. The next location content will be moved to CH register. The combinedly CH register, this corresponding location and next location will be moved. Look at this example. FFA2. So this is the address we are taking this. Actually this is A2 is a data. So signed extension data will be FFA2. Look at this effective address. We are taking the SI plus this data. This signed extension data, that is FFA2, that will be added. So physical address will be equal to data segment into 16 plus this effective address. So from that location content will be moved to CX. That indicates that present in the location will be moved to CL and next location content will be moved to CH register. Next one will be based index addressing mode. So we have seen this based addressing mode and indexed addressing modes. So combining these two, we will create an addressing mode, that is based index addressing modes. So here we use two effective addresses. One is a base address and another is an index register, and then we can use an offset also. Look at this example. Move dx comma bx plus si plus 0ah. So here bx is an base register, si is an source index register, and this 0a is an displacement value. All these three value will be added and this will be considered as an offset address. So actual value, that is a, look at this example. So base register plus SI plus the value will be added and this will be an effective address. So data segment into 16 plus this value, that is bx plus si plus 0a value will be added and that will be considered as an physical address. So from that location data will be moved to dx. So dx means it's a 16-bit. So we need to move this address content will be to dl and the next location content into the dh registers. Look at next one. This is string addressing mode. It's a special addressing mode. So string means group of characters. So group of characters will be available continuously. Look at this. So we use two registers. One is SI and another is DI. And similarly for an base we use two segments. One is an extra segment and another is a data segments. Look at this, the correlation for the source address. So we need to use this SI is an offset and data segment for an base register. So data segment into 16 plus this SI will be added, that is the physical address. Similarly, for look at the destination, so extra segment into 16 plus this DI will be added, that is the physical address for destination. So whenever you take a string, we need to have a source string and destination string. Source string means an input string and destination string is an output string. So after processing, the data will be stored to the destination location. Look at this example, simple example, move S byte. So actually this S indicates a string instruction. So normally we have move byte only now. So here move S byte. So here we have two combinations. One is move S B, move S byte, that is move S B, or move S W, that is a move S word. So word means it's a 16-bit, byte means it's an 8-bit. Again here important role is direction flag. So direction flag decides whether string is indicated from a starting location or a ending location. So whenever we are pointing with a starting location, for next character we need to increment. Whenever you point with an ending location, for next character we need to decrement. Look at this. If direction flag equal to 1, so SI will be decremented by 1. So SI equal to SI minus 1. Similarly, destination DA also DA equal to DA minus 1. So if direction flag equal to 1, so next character will be decremented to obtain it. It is indicated by a last location. Look at this, direction flag equal to 0. So that means next location we need to increment. Look at this, SI equal to SI plus 1 and DA equal to DA plus 1. So this will give the next location. So both must be same. So both source and destination must be incremented or decrement. Different combination cannot be allowed. Thank you.